equal lengths. Okay, so a lot of times you might want to make sure that you understand that a bisector cuts it into two equal parts. A lot of times some students don't make that connection. It cuts them into two equal parts. What does it mean to be parallel? Careful how you answer this. So beside each other without running into each other. Beside each other out. Into. I'll go with that for the moment. What is the symbol of parallel? When you're reading through the map, what's the symbol that we use to represent two things are parallel?
There are two lines.
Yeah. It's a pair of L's. Like parallel. Pair of L's. What does it mean to be perpendicular? All right, someone knows what Chris. Matt?
Like, they're running into each other.
Just any intersect? 90 degrees. Okay, so we have lines that intersect. At 90 degrees. What do we call the angle that's 90 degrees? Victoria? It's a right angle. So perpendicular lines are lines that intersect at right angles. What's the symbol for perpendicular? Perpendicular. What does that look like? Okay, don't make it simple. It's an upside down T. You'll see that tonight on your homework. At least on the challenge problem, you'll see that symbol. Before we talk about the point of concurrency, I want to go back to parallel. Bree tells us that parallel lines are lines that are beside each other.
We have a better one this time.
Okay, go ahead.
Okay, it's two distinct complementary lines that do not intersect.
Oh, that sounds awfully mathy. Two distinct lines, coplanar,
Yes.
that don't intersect. Very, very. I have a little blue line right here, says 108. I have another blue line over here that says 104. This is 100, 96, 92. What are those blue lines called?
Three.
They're the vertical blue lines on your map. What are they called? Longitude. What are the horizontal ones called? Latitude. Okay, good. All right. Follow me on your logic on this. If I take a line of longitude and I intersect it with a line of latitude, what did I just create? So I created a point. Well, what type of angle did I create?
90 degree.
A right angle. No matter which line of longitude you use, it intersects a line of latitude at a right angle, which means that the two lines must be, according to our definition, perpendicular. So your lines of longitude and lines of latitude are perpendicular. What do you know? If I'm looking at these two blue lines that I found on the page, what do you notice? What do they look like? They look to be parallel. And they should be. Well, we get to more definition of that, why they're parallel. Yet, so parallel lines. Two distinct coplanar lines that don't intersect lines of longitude, correct? What type of map is this? Be careful how you answer. Loaded question here. How many dimensions is this map? Two, length and width, right? Unfortunately, like I said, everything we learned in this class is completely false because we don't live in a two-dimensional world, and everything about high school geometry is two dimensions. Unfortunately, we live in this world. It's like the episode of Futurama where each one has the other person's universe in the box. But anyways, so I guess you should watch Futurama more. You'll get more of my connections there. Now, if I look at this, no matter where, again, if you look at them, it's just the individual. When I watch this line of longitude come in contact with that line of latitude, what does it create? A point, and it creates right angles, which means that the two lines are perpendicular, correct? And again, no matter where I go, if I go to the next longitude, it's still perpendicular to that same latitude, correct? Which means that the two lines of longitude must be parallel. Yet, anybody who's managed to get through the 6th grade and taken at least one geography class can clearly tell me that all your lines of longitude do what? They intersect. Interesting. So all these wonderful rules that we're going to learn about geometry only work in two-dimensional space. As soon as I take this two-dimensional rectangle and I try to transform it onto a three-dimensional sphere, I get a whole other realm of geometry called spherical geometry. And all types of weird things happen. For example, and I guess you know this from middle school math, how many degrees are in a triangle? 180 degrees in a triangle. Okay? So let me ask you this. So you guys tell me that lines of longitude intersect, correct? But if I have this longitude and they intersect here, correct? But in reality, these lines I now formed a triangle with more than 180 degrees. That's what happens when we leave our little two-dimensional world of geometry. Lots of weird things start to happen. Triangles can have more than 180. Parallel lines do intersect. It's kind of weird. Open your minds a little more. Math is all around you. So, back to this concept, point of concurrency.
I can't see. I really can't see.
Is the world in your way?
Yes. Your one's pale too.
Well, too bad. Deal with the launch pad. Point of concurrency. What is that? What does it mean? What can you guys tell me from that? Come on, second warning. Sarah.
The point where three or more lines intersect.
3 or more lines. Do we have to have 3 in order to have a point of concurrency?
You have 4.
We could definitely have 4. That'd be a little harder to get that point, but yes, we could have 4. Could you have 2? We need to have at least 2. Okay. Point of concurrency is basically what Sarah said. It's where 3 lines are intersecting. It's basically where at least 2 lines. That's where at least 2 lines intersect. And one thing I want you guys to be used to is what they have in common. So if I have, let's say I have 3 lines, and sometimes in geometry when our drawings don't work out, we make the point bigger. You know, you think I'm not. So you think you can't get your drawings to quite work, but you know what it's supposed to, just make your dot bigger. It'll work. So we now have our point of concurrency with 3 lines. Now, if I made 3 other lines, do I have a point of concurrency for this one right here? No, because there's not a point that all 3 have in common. So in order to be a point of concurrency, it has to be the point that they all have in common.